My name is Keshwani. It's Keshwani. Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 585. Please turn to page 585. Today is our lesson number 49. Let's take a look at it. The very first problem on page 585, it says m is the greatest prime factor of 38. M is the greatest prime factor of 38. Well, very first thing we're going to do is we're going to list all the factors of 38. All the factors of 38, all the numbers that we can divide 38 evenly into. Let's get going. Of course, the very first one is 1, because 1 can be any number can be divided by 1 evenly, obviously. So 1 is the first one. 38 can be divided into 2. 38 will not be divisible by 3 because 3 plus 8, the sum of the digits 3 plus 8 is 11, and 11 doesn't go into 3. It won't go into 4 because 4 times 9 is 36, and then comes 40. Obviously it's not divisible by 5 because it doesn't end in a 5 or a 0. It won't be divisible by 6 because it doesn't go into 3. In order for a number to be divisible by 6, it has to be divisible by both 2 and 3. Since we just said it's not divisible by 3 because the sum of the digits is only 11, so it's not going to be divisible by 6. It doesn't go into 7. I'm going to pick up speed now because it goes for 7, it goes 7, 6 are 42, and this is 38, so it's just 4 less. It's not going to go into it. 8 won't work. 9, it's not divisible by 9 because 9 4s are 36, as we just said. Not divisible by 10, obviously. 11 won't work because 11 would be 33, 44, and so forth. 12 doesn't work. 13, 14, 14. The very next number that we will come across is half of this thing, which is half of this thing. If you divide that by 2, how many 2's in a 3? 3 has 1, 2. The remaining one goes and joins this guy and becomes 18. How many 2's in 18? 18 has 9 2's, so that's the next one. And then 38. That's it. There aren't too many factors of 38. And our job is to locate the one which is the largest prime factor of 38. And of course, the largest here is 19. This is the prime factor, this is the prime number, and so is 19. They are both prime numbers, and these are all factors of 38. And the prime factors are the factors that are prime numbers. 2 is a prime factor, prime number, and therefore it's a prime factor. So is 19. Since our job is to look for the greatest one, this is our m, 19. Now let's do the next part. We are told that n is the greatest prime factor of 100. Is the greatest prime factor of 100. Again, first we're going to locate all the factors of 100, and then we'll ask ourselves how many of them are prime numbers, and then we'll look for the greatest one. So let's get going. The very first one is 1, then 2, 4 can be divided, 100 can be divided into 4 evenly, then 5, 10, 20, 25, 50, and 100. I hope I did not miss anything. I hope I just didn't miss anything. How many of them are prime numbers? Again, 2 is the prime number, and so is 5. None of the other numbers that you see there, none of the other factors of 100, are prime numbers. And the greater among the two is 5, which is our n. And they're looking for the value of m plus n. Very simple. M plus n would be 19 plus 5, which is 24. And that's our answer. Answer is 24, which is C. Let's go on to the next one, number 16. Number 16. It says L is a line L has a positive slope. All right. So we have a line L that has a positive slope, and we are told that it goes through 0, 0. So it goes through origin. Here's the origin, 0, 0, and it's a positively sloped line. We are calling it L. Then it goes on to say that if line K is perpendicular to L, which of the following must be true. Which of the following must be true? The most important word here is must. Not which of the following may be true. Not something that, now we are not looking for something that may be true sometime and not the others. We are looking for something that has to be true all the time. And therefore, the concept that they're testing here is that when we have two parallel lines, the product of their slope is -1. I'm not going to write all of this down. Here's what I want you to do. Instead of writing everything out, because they keep writing the same thing over and over again, here's what I want you to do. I want you to watch problem number 6 on page number 415, which is something that we covered on day number 7. Also, I would like you to watch problem number 10 rather, on page number 546. Page number 546, which is something that we covered on day number 43. Make sure if you have not watched these two videos, or if you have watched them, and if you don't remember what the problem was all about, turn to those two pages and make sure that you understand the concept that was covered in these two questions, because it's the same thing. Again, one more time I'm going to say it. The concept here is that when you have two perpendicular lines, the product of their slope is -1. When we have two perpendicular lines, the product of their slopes equals -1. So let's call this product, the slope of this line, M. M traditionally is the letter that is used to denote slope of a line. That's just a tradition, that's just a convention. And M with subscript L here would denote the slope of line L, which we are told is positive. And then we have another line which is called K. So here's another line K. Here's another line K, and they are perpendicular. They make a 90-degree angle. And because they are perpendicular, the slope of line L times the slope of line K has to equal -1. Well, we are told that the slope of line L is positive. We are told that line L is a positively sloped line. If line L has a positive slope and the product of these two quantities has to be -1, the only way the product of two numbers can be negative is if the other one is negative. Positive times negative will give us -1. It doesn't matter what their slope are. We don't have to actually figure out, we don't actually have to worry about what the exact slope are, because it is of no difference here. The only thing that matters here is that if one line is a positively sloped line, then the other line would have to be negatively sloped line, because that's the only way the product of two numbers is going to be a negative quantity. The fact that it's -1, it doesn't really play any role here. It's just a negative quantity. Therefore, the other line that we're talking about, line K, must be a negatively sloped line. And that's all they're looking for here. Line K has a negative slope. The answer is C. Line K is a negatively sloped line, as we can see clearly. But point we have to understand is that it doesn't matter where the line K is sitting. It makes no difference. Line K could be this one, or it could be this one, or it could be this one, or it could be right here, or it could be way up here. As long as it's perpendicular, then if the slope of line L is positive, then the slope of line K must be negative. Has to be negative, because that's the only way you can make the product of two numbers to be a negative. If one is positive, the other one has to be negative. Do you understand? That was it. Let's go to number 17. Problem number 17. In problem number 17, we are told that we have an operation that is defined as this. A with the arrow going up and a B. We are told that when we see that, this is a set of instructions. And our instructions here are that when we see that here, we are to take the number on the left hand side and add to it the number that we see on the right hand side. And then divide that sum by their difference. That's it. Those are our instructions. The question is, if 1 arrow 2 equals 2 arrow x, then how much is x? That's all it is. So let's find out, shall we? We're just going to follow the instructions, that's all it is. 1 arrow 2 means we take 1 is on the left hand side of the arrow, so A is on the left hand side, so it's A plus B, so here it's going to be 1 plus 2. 1 plus 2 over 1 minus 2. 1 minus 2, and that has to equal, we are told, 2 plus the x over 2 minus the x. And all we have to do is solve for x. That's all there is. It's a simple linear equation. We just have to solve for it. So 1 plus 2 here is 3, and 1 minus 2 is negative 1. So let's put it here so it's easy to see. 3 over negative 1. And then cross multiply. When we cross multiply, we get 2 plus x times negative 1. 2 plus x times negative 1. And here we're going to get 2 minus x times 3. 2 minus x times 3. And like I said, all we have to do is solve for x. Simple linear equation. 2 times negative 1 is negative 2. And x times negative 1 is negative x. And here we're going to get 3 times 2 is 6. And 3 times negative x is negative 3x. Let's add 3x to both sides. And let's add 2 to both sides. Here we have a negative 2 and a positive 2, they're going to cancel out. And here we have a negative x and a positive 3x. A negative x and a positive 3x is going to give us positive 2x. And here, a negative 3x and a positive 3x will drop out, and here we get an 8. 6 plus 2 is 8. 2x equals 8, and therefore x equals 4. That's it. X equals 4 is the answer. Answer is A. Answer is A. And that's all it is. We just have to follow the instructions that are given to us. We are done with this one. Let's go to number 18. Let's go to problem number 18. It says, during a sale, a customer can buy one shirt for X dollars. Alright. 1 for X dollars. Each additional shirt that the customer buys costs Z dollars. Each additional costs Z dollars. Alright. Or rather, let me read the whole thing. Each additional shirt that the customer buys costs Z dollars less than the first one. Sorry, Z dollar less than the first one. Alright, that's very important. The question simply is, and then they go on to explain it. For example, the cost of the second shirt would be the cost of the first shirt minus the Z. X minus Z. Z dollar less than the first one. Which of the following represents the customer's cost of N shirts? So we're going to buy N shirts. Now listen, there are two ways we can go about this problem. This is an algebra problem, and therefore there are two ways you can solve it. You can solve this problem algebraically, classical. In other words, we can solve this problem in a classical manner, traditional manner, orthodox manner, in a geeky way, in a nerdy way, in an algebraic way. Or we can solve this thing in a non-classical manner by plugging in numbers. We can do it either way. Let's do it both ways. Let's first do non-classical way by making up some numbers, and then we'll do the algebra. Okay? Let's see what happens here. So make up any numbers that you want. Make up any number that you want. Let's pretend that the first shirt, let's pretend, costs $10. We're also going to pretend that each additional shirt costs $2 less than before. In other words, each additional shirt is going to cost $8. You see, based on the numbers that we plugged in, each additional shirt is going to cost $8. The first one we have to pay $10, and each additional one is going to cost $2 less. The question is, how many shirts do you want to buy? Keep your numbers small as possible, because bigger the numbers are, the more calculations you will have to do. Let's buy 3 shirts. Let's buy 3 shirts. So how much money will we spend? We'll pay $10 for the first shirt. The second shirt is going to cost $8, and the third shirt is going to cost $8. That's it. That's what we will spend on 3 shirts. 8 plus 8 is 16. 16 plus 10 is 26. 26 is what I call our punchline. This is our punchline. This is our answer. The question here is, what's the cost of 3 shirts if the first shirt costs $10 and each additional shirt after the first shirt costs $2 less than the first one? Which is a very roundabout way of saying that each additional shirt costs $8. So that's our answer, 26. What we're going to do is, we're going to go through the answer choices. Wherever we see X, we're going to replace it with 10. Wherever we see Z, we're going to replace it with 2. Wherever we see N, we're going to replace it with 3. Until we come upon a quantity that works out to be 26. That's all. Let's look at the first one. The first one says X plus N minus 1 times X minus Z. Well, X is 10 plus N minus 1. We are buying 3 shirts. N minus 1 is going to be 2. And X minus 2 would be, X is our 10 minus 2. 10 minus 2, which is same as 2 times 8. 10 plus 2 times 8, which is exactly what we had here. 10 plus 2 times 8. Therefore, the answer is A. That's it. The answer is A. And if A did not work out, then we would have kept on going until we find something that does work. We're looking for 26, and A works out to be 26. Now, how would we do this question algebraically? Let's find out very quickly, shall we? Algebra actually is not that bad in this question. Let's do it algebraically. I'm going to erase everything because otherwise it will get to be too crowded. So, it's very simple. The first shirt costs X dollars. That's the price of the first shirt. Each additional shirt costs Z dollars less than the first shirt, which means each additional shirt costs Z dollar less than the first shirt. So it's X minus Z dollars. That's the cost of each additional shirt. So if we buy N shirt, how do we represent that? Well, if you're going to buy N shirt, that's your first one. If N is 10, that's the first one. We have only 9 left. How do you represent 9 using the N? 9 would be, if N happens to be 10, we will write 9 as N minus 1. That's your 9 shirt. N minus 1 shirt is, this is the first shirt, this is N minus 1 shirt, and then this is the cost of each of the shirts. Therefore, the total price is the price of the first shirt, which is X dollars, times N minus 1. N minus 1 because this is the first one. So if we're going to buy N shirt, then we have leftover is 1 less than N. And the cost of each one of them is X minus Z. There you go, that's your answer. That's your A. That's it. That was the answer. I will see you tomorrow, okay? This one was classified, number 18 that we just finished was classified as a hard question. So you have to take your time. Otherwise you're going to end up making a boo-boo. Do you understand? I'll see you tomorrow, okay? Bye now.